So, welcome, ladies and gentlemen. This is the 5G Super-BluePrint presentation project. My name is Gervais-Martial Ngueko. I work for AT&T as a principal design for some time now. And this project is really a first step toward the 5G deployment platform. It has been developed with the help of Ericsson and HighStreet, and with some other developer of AT&T. I will cite a few names here, like Christophe Closset, Sébastien Determe, and Shui Gao. So the plan here today is for you to understand the Discover project, understand it, and hopefully later on be able to contribute to it for the best of us. And in order to understand it, I've left some time at the end of the session for Q&A, so you can ask whatever question you need in order to clarify any doubt you will have on the presentation. So let's look a bit at the agenda. So I will start with an introduction, then I will walk through the challenge and solution that we encounter, then a little dive into the technical approach, and to finish, we'll see the next steps with a little summary animation, and then the open discussion with the audience. So first, let's put some context into the project. That context is the 5G Super-BluePrint that you heard about during the keynote. So this is a LFN initiative to establish an end-to-end platform to test 5G and to help grow 5G into the community. And our project is really to help settle a new platform for that 5G Super-BluePrint development. And also a quick note on the name SMO. This name SMO is the Service Management and Orchestration for the Open RAN, and this is where the name SMO is coming from. But I'll come to that a bit later. So, the challenges. The challenges we have is really about the fact that we have various ecosystems that are involved, that are progressing at their own pace, and that you need to bring together and keep it consistent so that we have always a working platform. And since all those ecosystems are evolving at a different pace, you really need to take that into account. So the solution we came up with has some main guiding principle. The first guiding principle is to really not reinvent the wheel. You should really reuse everything that is available in the community. And that's what we did in the first place by reusing a lot what was done in ONAP with the OM project, and that we extend at some point in order to have something that goes beyond ONAP. We wanted also to keep customization at the minimum so that you don't need to change your project in order to integrate into the SMO project package. Some key highlights I can mention here is that we really set as few requirements as possible. We want really to be the reference for the 5G Super-BluePrint development platform. We made our solutions so that it can be easily extendable, and also being able to be installed on different lab and platform depending on your particular situation. So let's dive into the technical approach that we implement. And before that, a quick refresher on ORAN, because as I said before, the name of the package comes from the SMO, so the Service Management and Orchestration Framework of ORAN. That's because this was the support for the implementation of our project. This is kind of the first use case that we leverage in order to implement the SMO package. So in the technical approach, we define what we call flavor. This is to set different size of deployment depending on your need, because we understand that not all the time you need to deploy everything in your system. You may need just few bits to be deployed in order to test your environment. So we came up with flavors which are just a predefined set of platform and environment that you will deploy for your use case testing. So to come to those flavors, we had quite some discussion with the ORAN SC community in order to define what will come in each flavor, and also to define the use case that we will be using, and so on. So the ORAN SC was really a good part of the decision we took to implement that project. So at a high level, the SML package works by feeding off charts which are in Git repos for different projects, and those charts feed the main engine of the SMO package to allow you to run the different scripts that implement your use case that you want to test. The implementation is made by layer. So we start by deploying the very first layer of the infrastructure, so the VM, Kubernetes. And then on top of that, we have all the Helm part, starting with the Helm build to create the chart and to put them in the chart museum. And after that, the actual deployment of the different components that you have decided. And we also leverage the Python SDK, which is a set of libraries that you can use to trigger the different operation you want on the different components which are part of your SMO package. And we made that approach by layer to really put flexibility on the way you can deploy the SMO package, so that depending on your need, you may skip one layer if you don't really need it. Here I want to put some emphasis on the Helm structure that we defined for the SMO package. This is because everything starts with the chart. So in order to be able to orchestrate the chart that are part of the SMO package, you really need to follow some standard that we have defined for the chart. There's no magic here. It's really about exposing the parameter you need, and to be able later on to connect the different charts together to create your complete platform. The next use case that we are targeting with the SMO package is the network slicing automation, and precisely the one that was set up in ONAP with the network slicing use cases. Here is just some example of the options that are available on ONAP to deploy network slicing. It's not yet all done because it's a huge task. And we are starting with option 2 because it's the simplest. The difference between the different options is the component of the network slicing that are part of ONAP or not. For instance, between option 2 and option 1, the difference is that the NSSMF is not implemented in ONAP, but is an external entity that it is triggered by ONAP using standard API. So what we did with network slicing is to deploy and then do the testing itself. And we reached the point where we were able to do the deployment, but we still need to complete the full work by implementing the workflow. At this point, we have just been able to do all the onboarding and configuration of the different elements that are part of the network slicing. And now there is the other part, which is about creating the workflow that really orchestrates network slicing and creates slice. Because this is really a huge project that requires a lot of configuration before being able to really orchestrate your workflow. So what we envision for the next step with the network slicing is to first finish the workflow implementation, then go and implement the option 1, which is a bit more complicated but more complete as a network slicing use case. And then to finally being able to use that option 1, but not only with simulator, but with real equipment in order to do full testing end-to-end with real equipment. Where we are today with the SMO package. So right now we have implemented everything which is in red here. So using Kubernetes and Docker, ONAP and SDN controller of ONAP. So we have used Open Daylight, the name is coming back. And we have also used ORAN and user edge via the simulator. So you see there is still a lot of room for completing the SMO package with some other component depending on your need. And this is where we need the community in order to help us implement even more elements into the SMO package and to really complete a platform that can be used to leverage 5G Super-BluePrint, implement our reference platform the way we want. So this is already, the SMO package is already being used as we speak. And it has been deployed on some labs already, so the Cosmos labs, the Porto lab, both our university in New York and Salt Lake City, in AT&T obviously, and also in the SoCal University for the Sabre initiative. And we'll hear about Sabre most likely this afternoon because Dr. Klein is here and we'll touch on this project, which is about security for network slicing. And on the UNH Lab for ONAP and also for the University of New Hampshire. So what's next? What's next is to be able to enrich the SMO package with some more tools, like Wireshark, Keycloak, to even touch on more use cases, like network slicing and 6G and even more. And like I mentioned, Sabre or any other initiative that the committee can come up with so that we can really complete the SMO package with more elements. So I will play here a summary video to really give you an overview of what the SMO package is doing, and so that you can have it as a takeaway.
Welcome to the SMO package summary presentation. This is the first step towards an automated 5G testing platform for everyone. First, let's look at some requirements Helm chart needs to satisfy for the SMO package. No magic here. It is just about exposing properly all the chart parameters needed to deploy the components with the SMO package. It also means, for instance, to avoid using shell script in the middle of your component deployment instead of relying on proper usage of Helm features. The reward charts are called SMO standardized chart. Those SMO standardized charts should become the new official chart of the components to be used inside or outside SMO package. Let's now see how the SMO package is organized in Git and how it uses Git submodules. The SMO package chart is organized in Git as an umbrella chart. Under the umbrella, you have a submodule for each project. So each project can be managed independently from each other. We have two cases. The first case, the official project chart are not standardized and the submodule cannot be directly linked to the official project chart repo. The second case, the official project chart is standardized and the submodule can then be directly linked to the official project chart repo. We have also a dedicated submodule for the SMO package internal tooling chart, such as Jenkins, Python, and more. The whole orchestration is done using an Helm override file that can configure each submodule depending on the deployment needed. Let's get an overview of the SMO package orchestration in action. The very first task for someone using the SMO package is to get the actual package from Git. After that, the user from his computer can orchestrate the deployment of the platform. That orchestration is organized by layer, starting from the virtual machine deployment, followed by the Kubernetes deployment, which itself is followed by the Helm orchestration. Helm orchestration has two parts. The first part is the build of the package into the chart museum. The second part being the actual deployment of the components. The whole orchestration is made by layer for flexibility. That way you can adapt, skip layer not needed in your particular situation. Having now a deployed platform, you can play your use case scripts thanks to the Python SDK library. The Python SDK library is a Python wrapper on the REST API exposed by the different components available in the SMO package. That library is extendable, and you will actually need to extend it for each new component introduced in the SMO package. So, using the Python SDK, you can now write and then execute your various use cases via Python scripts. These script executions are illustrated here with the two animated test cases. That's the end of the animation. I hope you enjoy it. Thank you.
Okay, so that's the end, like I said. And now the floor is for you to have a question that I can answer.
So can you go back a couple slides to the one where you just for the stream, I guess.
Yeah.
Oh, sure. Yeah, if you could go back to a couple slides where you just show the blueprint. Just any one of the slides that shows the blueprint.
Okay, maybe I will put the slideshow, it will be easier. This one? No.
Just the one that shows the blueprint. It's got, there you go.
Okay.
So what's the status of Magma? I noticed you didn't use that. And
Yeah.
I'm curious how you're doing slicing without a core.
Right now, this will be more a question for the network slicing use case in ONAP. But yeah, there is not yet a core for the full workflow of network slicing. And this is something that is still being worked on by the network slicing use case to come up with a core that will be used to have the full end-to-end flow for network slicing.
So do you know what the what those universities you listed? You said Powder and
Porto, Cosmos.
Rutgers, yeah. Do you know what core they're using?
No, I know that there is the free 5G core. That is the front runner to replace Magma, but it's not yet established as such.
Okay, thanks.
I don't know if Liam, you want to maybe put some words?
Yeah, we really, I suppose my role and or our role in this was from the ONAP point of view of bringing in the policy framework and also the clamp composition work, which was used as a part of this. And I think there's two points here. You know, SMO, I think, and say Open RAN is, you know, it's a really interesting initiative, but it is struggling a little bit on the, you know, on the agreeing what it is a little bit, and I think this work was very important because it shows that like, SMO is something that's real, something that can be built, and it also then from an owner point of view, I mean the amount of support that we had to give to you was, you know, was very small, minimal really. I mean it shows that, you know, that, you know, building orchestration things on top of ONAP, you know, is possible, and it is actually, I wouldn't say extremely easy, but it is. But in this world where, you know, everything's tied together with charts and scripts, it's really the components can do what they do. It's the integration of it that's now the challenge.
Yes, exactly.
I think. But this was a, you know, a real validation for us of the work that we're doing, because, you know, in a complex system like SMO, we were able to bring the ONAP policy, I suppose, and DMAP components across without too much trouble into this environment. Yeah. So that was my takeaway for this. I really, there was a longer presentation on this done at the DTF in May, where you actually went into the details.
I didn't want to go here into the detail because I don't know the audience knowledge, and I wanted to keep it an overview so that you get a taste of it and.
But dig into that if you're interested, because this is a fascinating. This is a fascinating initiative.
Too much.
Thank you for the presentation.
Thank you.
Just a question in terms of how much of this can be used for production grade, you know, in terms of deploying in the live environment. What is the thought process in terms of using that?
Well, this was mostly thought to be a kind of a lab environment. It's not a production grade. This is really more to support the 5G Super-BluePrint so that everyone can come and test his specific 5G test case or features and collaborate with other 5G players in order to see that everything is flowing together the way they want it to be. But it's not meant to deploy your production environment with that. It's not the idea here. It's really a lab for experimental stuff, and that's it.
Yeah, I understand that. Just I wanted to understand the potential, you know, whether some of the components, do they have a potential to get deployed in a production grade environment?
Yes, for sure, because the charts you use here are supposed to be the same chart that you will use on your production. So the goal when we create the SML package is to really keep the customization at the minimum. So normally you should be able to take the charts that you have for your production and use it on the lab without problem. Of course, you need to have exposed the parameters that are needed properly. That's kind of common stuff to do. So that you're able to connect the component with other components using your chart without any customization. But aside of that, there's nothing more that you should do.
Thank you.
Thank you. And what is the component you're using for bringing up the bare metal? The bare metal bring up the layer 0.1 scripts.
Yeah. Well,
what is the component for that to bring the bare metal stack?
I don't get what the component you need to bring.
No, when you explain the scripts, there were layer 0, layer 1, right?
Okay.
So the layer 0 scripts.
Yeah.
So what it is utilizing to bring up the bare metal stack, the OS component, and the Kubernetes stack on top of that? The scripts layer 0, right?
Okay, yeah.
What those are made of?
Well, it's just about taking your it's shell script actually. It's just shell scripting that we use to deploy the VM. You have some standard VM that you have, and you use shell scripting to deploy it on the VM. So there's nothing special.
No, I was trying to see are there any. So there are projects which are kind of Metal LB, which brings up in the CNCF to bring up a Kubernetes cluster itself, right?
Okay.
So I was thinking that whether you're using another open source component to bring it up, or you're using just some scripts.
No.
That's what I was trying to understand.
No, that is. But if you have something new like that, please come forward and you can add it to the package.
Yeah, you can look at Metal LB in CNCF. So they bring up a Kubernetes stack.
Okay.
From the bare metal.
Okay, that's great. Some more questions?
So maybe, Martial, you can invite the team to look where they can find also the code. And
Yes.
as mentioned by Liam, there are a couple of demos where we went through more details, more technical details that you can look at. It was presented at the Porto event in June, and it's still current. What is maybe missing is the network slicing part, because at that time in Porto, everything was not yet finalized on the network slicing, with the network slicing use case. But otherwise, there are more details for the technical people. And very good demo, as mentioned by Liam. So we want to invite you to take a look when you have 2 minutes.
Yeah. So yes, this is the reference page that you can go to get more details if you want to. So you have the wiki here, and you can also ask questions on the wiki. We answer them regularly, so we are active there. And you have the link to the Gerrit package itself on Gerrit. And the meeting page on the ONAP wiki, where we also are active there. But yes, like Catherine mentioned, in this presentation I didn't want to go into too much detail because the audience is not as technical as it could be. So if you want more technical detail, there is the audio recording of the Porto event that has a bit more technical detail if you want. But also in the wiki, you can go there and you'll have even more detail. Yeah, yes?
So what's next on the roadmap?
So the roadmap will depend kind of a lot on the community because if there is more community members that are coming into the contribution here, it will help us, help me at least, convince upper management to invest even more to the SML package to bring more feature. So at this point, the roadmap is not fixed. It's really open. It will depend on community reaction in order to continue more and go in search on another direction.
But I think you give some hints today, right?
Yeah.
So if you're interested, the team kick off the network slicing, which is what they are doing now. But we are lucky. If you have time this afternoon, there is another presentation with Dr. Klein, which will really focus on how we can secure network slicing. And that's really the next steps that the team is trying to integrate with Sabers. And also, you were mentioning something else. Go away from my mind. You have two other items on the roadmap that you have presented. There was a network slicing, and the other option, there is the Sabre integration and other option for the network slicing to be more complicated.
It means 5G, 6G, and other automation. But beware that for the 5G, 6G, this actually depends on the implementation by the use case team themselves, because we are kind of just, it goes automating what they are doing manually right now. So we cannot advance more than the speed of the use case team is doing. And I know that, for instance, they still have some bugs that are encountering in the different components of network slicing, and so it's not yet complete. But yes, those are the areas that we plan to go toward, but it will all depend on what the community tell us to go, actually.
Are you aligning with any organizations like ETSI or on the 6G standardization, or you're aligning on the roadmap in certain?
Well, not specifically, because they're kind of independent. We are just setting up the platform, and on that platform you will be able to test your standard. If you want to test the standard 6G or 5G, you will be able to use the platform to test it. So we don't need to align as such to the standard directly.
So from an ONAP perspective, there is a lot of alignment with different SDOs like ETSI, TMF Forum for the API. We are also looking from camera. There is another talk at the same time about camera. 3GPP, so I'm sure I'm forgetting others. So the upfront work from a standardization is happening with the ONAP community. What has been presented today with Martial is really how we can select some ONAP component to deserve the Open RAN needs, acting as a service management orchestrator on the non-real-time rig, right? That's really the purpose here. So they take the best of the component and the enhancing, and they also try to validate some use case, implementing some important automated testing.
Yes.
So when people want to enjoy and play, it's already functioning,
yeah.
at least.
So yeah, like I said, the first use case that was used to validate the SML package is the ORAN, and more precisely the non-real-time rig part, and using some simulator. And tests that have been done are with the O1 and A1 interface. And those are the ones that are currently being played, and more to come.
David?
So where in your roadmap then would be also support for the O2 interface? I mean, if you were going to go and merge with ORAN and support ORAN, we've got to deploy the ORAN way. Mm-hmm. So what is your roadmap for supporting the O2 interface?
Well, that's not depend on us. That roadmap it will depend on the advance of the different of the ORAN SC itself. When they are ready to do that, we are there. They will be able to use our platform to test their O2 interface. So that's not an issue.
Any other question?
Okay.
So thank you, Martial, to share more insight.
Thank you.